Okay, so what we're going to look at today is the wave function. Now the wave function basically is what is the resultant graph when we add a sine and cosine graph together. Now this can be used in a number of kind of real life situations. So for instance, the interaction of sound waves, or the tides where two bodies of water meet. And it's obviously all about trigonometry. So basically we're looking at combining waves and seeing what that gives us. Okay, so what I've done so far is I've worked out all these values. Again, just use your calculator. We should know obviously sine of 0 is 0, sine of 90 is 1 and so on. Sine of 45 obviously we know is 1 over root 2. But I've just put it as a decimal to one decimal place. Now what we're going to do is we're going to add sine x and cos x together. I'm going to plot that graph. So 1, 1.4, 1, it's going to give us 0, negative 1, negative 1.4, negative 1, 0 and 1. Okay, so what I'm going to do is I'm going to plot all these values along here. So at 0 it is 1, let's just say 1 is there. At 45 is 1.4, so let's just say that is there. Then it goes back down to 1, so it's there. At 135 it's at 0. Then it goes to negative 1, so I'm going to mark on where that's negative 1 there, so that's going to be there. Then it goes to negative 1.4 at our next one, which was 225. Okay, so that's in there. Then it goes back to negative 1 at 270, 0, and then back up to 1. And if we join this up, go. Now, depending on how you look at this, you can see that it represents a sine or a cos graph. Now, if we first of all maybe start thinking it as being a cos graph, you'd imagine it almost starts at that point there. Okay, so at 45 degrees, if you look at there, you can see it represents a cos graph that's been shifted. So, what's the maximum? Well, the maximum is 1.4. What's the minimum? Minus 1.4. Where does the maximum take place? It takes place at 45 degrees. And where does the minimum take place? Well, it takes place at 225. So what we can do is think, well, how could we represent this? Well, it will be 1.4, because that's how many it should be multiplied by, cos. Now we know that cos normally starts at 0 and now starts at 45. So x minus 45. So that is one way to represent it. Now, depending on how you interpret it though, it could also be designed as a cos graph that's been shifted backwards, or it could be interpreted obviously as a sine graph. So imagine we were saying it as a cos graph that's been shifted backwards. So where else do we have a maximum? We'd have a maximum here, which would be at 405. Okay, so what you could say is that you had a graph that starts there, so it's been moved completely back the way, 315 degrees. Okay, so that's one way of thinking about it. Now, if you think of it as being a sine wave, now our sine wave, if you imagine, would be down here. Okay, you could imagine it starting down there, which will be at 45 degrees. So that's moved back 45, so that one would be 45. Another way to think about it is obviously it's going to end kind of all the way along the x-axis. So we can imagine it's been shifted that way, 315 degrees. Okay, so obviously it repeats itself. So between the 360 and the 45, we're getting this 315. So the main thing is that we have a relationship, sine x plus cos x. If you add them together, you actually get a wave that can be represented by cosine or sine. Now our aim is basically to do that. So our aim is to change cos x plus sine x, or any two trig functions added together, predominantly sine and cos is what we're going to look at, and we're going to put them in the form of a cos graph or a sine graph. Now we're going to do it using an algebraic method because we don't want to draw it. And the main thing is that the questions will always tell you what form they want you to put it in. So, that's example 1. Cos x plus sine x. What we're going to do is we're going to put it in the form k, which is going to be the number at the front, x minus, now I kept word writing alpha, so I'm just going to put a. Where have you seen cos of x minus a before? You've seen it on your formula sheet. So we're going to go to our formula sheet. Now I'm putting a bracket in because it's k times the whole thing. So cos x, cos a, minus goes to plus, remember, look at your formula sheet, sine x, sine a. we multiply both of those, I mean technically I should alpha. Okay, and that is equal to this. Cos x plus sine x. So we're taking the expansion they're telling us to pick, which is cos of x minus a. We're using our formula sheet. Our addition formula from trig before, and then we end up at this point here. Right, now because this is an equation number, these are equal. So what does that mean? Right, well that means, I'm going to change our colours up. That if we have a cos x, we have a cos x there. So whatever is in front of the cos x must be the same as whatever is in front of this cos x. Now there's nothing there, so technically there's a number 1. So what we can extract from that is that 1 equals k cos alpha. Okay, we're going to do the same with the sine x's. So we have a sine x there, we have a sine x there. Oh, I forgot my k. Oops. That's what you shouldn't do. So k sine alpha is the same again, what's in front of that sine x, which is the number 1. So we can say that 1 is k sine alpha. Now for the purposes of this makes sense as we go on, I'm going to rewrite these so sine's on top. Now we'll also do this if I had things like negatives. And as we go on, you'll see why. Okay, now what we need to establish is we need to figure out what's the number at the front and what is the angle that we have shifted this by. So first of all, to get the number at the front, which is k, what we're really doing is we're really trying to get the height of this graph. To get the height of anything, if we know the vertical and the horizontal, we are going to use Pythagoras. So to figure out k, it is the square root of each number squared. Basically it's Pythagoras' theorem, but it's like the amplitude really. The magnitude, sorry, not the amplitude. 1 squared plus 1 squared is root 2. Okay, so that is your k. So basically to get the height of this, it's Pythagoras' theorem combined into one. Right, to get our alpha. Okay, now we currently have 2 trig functions, sine alpha and cos alpha. We don't want to have 2, we want to have 1. What is the relationship we know between sine and cos? Well, we know they give us tan. So what we're going to say is k sine alpha equals 1. Now, to make this tan, I need to put them over each other. That's where I write them the way I do. K over k's cancel. 1 over 1 we know is 1. So what we're actually left with is tan alpha equals 1. Now, like in normal trig, we have to know what quadrant we're working in. So we're going to take these two, and obviously they're both positive. So sine is positive and cos is positive. So we're just dealing with the first one. So alpha is tan to the minus 1 of 1, which we know is 45 degrees. So therefore, cos x plus sine x, like we proved earlier, now root 2 is roughly 1.4, but we leave it as root 2. So look back at the question that I've underlined up here. We've got k, we've got our alpha, and that's how we would do it algebraically. So initially we did it as a graph. It took much longer, and it's also just a bit more complicated to try and kind of think through what's happened to the graph, but that is how we do it algebraically.